Next, let's create the logic for this lost object. Before creating the lost object, let's close Living Qt. Right, it's open again. Let's close it. Never mind, it's a small detail. Then, we should need to create a blueprint here. Let's create the blueprint first. First of all, we definitely need to create something like a pickup item. So let's create this PK app first. This PK is just a very simple carrier. It serves as a tool for our gun. Then we'll proceed to create our projectile. This projectile requires us to inherit from our C++ class because it has some logic that is more suitable to put in C++. Okay. I shouldn't have misspelled it. Let me take a look. Let me check. There should be no spelling mistake. Okay, so let's ignore this for now. We'll leave this blank for now. We might write this last. Let's first complete the loss logic. As for the loss logic, right here, first we need to add components. The first thing we need to add is the component we wrote ourselves. The first one is our weapon component. Obviously, we can't find weapons like this, right? Similarly, we probably can't find pickup either. The reason might not be found because we haven't written anything here yet. It is said that this component of ours actually hasn't been defined in blueprint yet. So that blueprint can use it. Then let's put this aside for now. Let's put these two classes aside, and then let's start writing directly. Okay, this is the throwable object. We haven't written this one yet either. Let's scratch it out. Let's start writing some code. Okay, yeah, let's open a C++ project. Then we'll go ahead and write the pickup logic first. The pickup logic. So what is the pickup logic like? First of all, we need to modify this class. First, it definitely needs to be used in the blueprint system. So we give it the two most commonly used ones. That is, it is of table and type. Then in this way, we can use it as a variable in Blueprint. We can also create a Blueprint class like this. Then for classification, we classify it into this cask. Then we give it a Blueprint generated components element. Okay, after we finish it, we declare this delegate here. This delegate is mainly used to implement. After implementing the collision trigger this delegate, we'll just ignore it for now. Then here, because we will need to use this character later, when colliding, use a counter. We include it here. This counter will be enough. I think it should also be fine to forward declare it, since there is no dependency relationship here. So we can just include it directly, which is also okay. No problem. This is a dynamic one, a multi-we parameter delegate. That is, when collision occurs, this delegate, we can manually trigger it. So first we need to give this delegate assailable. Assailable means, in Blueprint, we let it be readable to implement. Create its actual implementation. We compile and get an error. Let's check the reason for this error. The reason for the error is also very simple. It's because the class name here is written incorrectly. Okay, then let's compile again. Okay, so this should be fine. Let's move on to the next part. So this thing, it definitely has a constructor. So we bring the constructor over. No problem. Okay, so after the constructor, we definitely have a begin play. Here, because we need to register. Right. So here, we'll create it. These implementation methods. Okay, so in this place, in this constructor, we can adjust the radius. Because it inherits from the collision box. That is this software. This software context, it is actually a collision box. We often use it. This thing, this parent class, this is something from the parent class. It can provide us with some bindable things we can implement. Then first, we must remember to call superBeginPlay. We must remember to call superBeginPlay. Then we add a collision trigger event like this. Trigger a trigger event. We haven't written this method yet. Why haven't we written it yet? Because this event is a method within its parent's popper, a method for starting overlap. You see it here. So this overlap has a signature, and its parameter signature looks like this. It looks exactly like this. We can move it over here. After moving it over, then this function signature, because it is dynamic. So this function must use function, otherwise you won't be able to find it. So how do we write such a method? So when you write normally, we can copy here. When you have no code to copy, you can only look for the parameter type declared by his proxy. Then we can bring over the parameter type he wrote. We just need to match them. Okay, let's bring over what he wrote. And obviously he likes to have a function. So basically just ignore the first three. Then here, this is a km parameter. You can see we break it down line by line. This way it becomes clear to you. This blueprint collision, you should use blueprint overlap. You should use it often. Now it's just written in a different syntax. There shouldn't be any problem either. Okay, here. You can see it here. You will find this function signature. It is exactly the same. This solves the issue when you sometimes bind a leader. You don't know why it needs to be written this way. This U function is the reason for the dynamic. If you don't add this U function, it won't find this method. Just call function on one side. And these things are all protected. It also proves that other places won't let you call it. Okay, let's create its implementation. Okay, here we can put it like this, so it looks better for everyone. Okay, good. This is when a collision occurs. When a collision happens, the work we need to do is actually very simple. First, you must convert it into this character. Then this character must be this one. Because we only implement this functionality with this type of class, it could be that when it collides, it might be someone else who fired this bullet. Or it could be some animals in the scene, that we do this through casting. But each time you cast, it is a performance cost. Therefore, try to avoid casting as much as possible. Especially with blueprint casting. You should use it sparingly. Using it a bit in Key++ is fine, but you are currently in the beginner stage. You don't need to be so meticulous about this, because when it comes to performance optimization, actually 80% of our performance issues come from only 20% of the code. Obviously, this cast does not belong to that 20% of the code, so this part can be ignored. Then, as long as this check succeeds, we trigger this dynamic multi-wave. Yes. Trigger this dynamic multi-wave. Then, after the trigger is completed, we remove this collision event from it because we only need to trigger it once. So, how should the logic inside this collision event be handled? Then we will handle it right here. This box means it has a one-time collision effect. Okay, good. Then let's go back to wait call. In wait comp, we need to implement the logic for the weapon component. First, here, let's confirm that the compilation should pass. Since my machine is relatively fast, I'll compile it frequently for everyone. Actually, during our development process, you really need to compile. Often, you can't write code for a long time and then compile it later. And for large companies, they usually have a pipeline, meaning you might submit code every day. Every time you submit, after you submit, it might take 3 to 5 days. Then it will not only package, that is not manually packaged, but packaged through a pipeline. It will automatically fetch all the code from your GitHub, and after packaging, it will run performance analysis on its own. Generally, in large company projects, this entire workflow is in place. For now, just know that this exists. Then we will write our component here, and then we'll just move these three brothers over here. Then we will definitely use an actor. Here we'll use the forward declaration we wrote. Right, because we need to attach the component to this actor. Use a forward declaration here. Similarly, we need a public member here. We'll do some simple setup and processing for its variables. Here, we'll go through them one by one and explain as we write. First, there is a subclass. This type, FPCSimplePickupComponent. Then we need it must be a subclass of this. Belongs to T subclass of. This is our projectile. This is a UCopy type. Do you still remember the class object we talked about earlier? The concept of the class default object. This is a class object. That is, it points to a class. It is not a real object. It indicates a category of a creature. Okay. And here is sound base. What is this? This is sound. We call it sound effect. This is remember the sound profile we learned in the previous 2 chapters. Right. It is a subclass of a sound effect. Next is a montage. When we play the animation, we definitely have a montage. So just put it here. Then this vector. It is actually a 3-dimensional vector. And then you can make an offset. That is called a muzzle offset. Then next is us. Because this component needs to... What is this called? Our input. We need to add a new input mapping for firing. So here we need to specify which key triggers the firing. You're using the left mouse button now. Maybe you are working on a project and you want to use the right mouse button instead. You make another project. You may want to use E or R. Then you can create a new sound like this here. And this kind of forward declaration is also acceptable. This kind is written here from the start. Yeah, you might just write it wherever you use it. This kind of forward declaration is also fine. Personally, I prefer to write all of them at the front. But sometimes writing it here is also clear and concise. And this is specifically for when you need to continue binding each mappy. Then, after these things are done, we will write our constructor here, because we might have some things that need to be initialized here. So, there is a constructor, right? Okay. Then we have two methods here. These two methods are what we need to call. It essentially means that when we complete this, attach weapon, and when firing, there's work that needs to be performed. Then, next, when we end the delegate, we may need to perform from that underplay. Well, it's just override, such an overriding method. And here, we need to hold on to the object we are attaching to, because sometimes we might need to drop this pointer, but here it is a bar pointer without red marking. This kind of writing is actually quite dangerous. Okay, alright, now let's go into this constructor. Let's take a look at what work is done inside the constructor. First, inside the constructor, it actually provides a default muzzle offset. Yes, so that means this part should be used to control the spawn location of the projectile. It might need some adjustment. Then, next, we mainly need to implement. These are all assigned assets. We mainly need to implement this attach weapon. That is, when we trigger it. How do we trigger this as attached weapon? This method needs to be called in blueprint, because we have a blueprint layer in between. So this is called in blueprint. Then attach weapon. How does it work? First, what you pass in must be an actor. A pointer like this actor is stored here. And here you must ensure that this character is class. The character must exist. So we need to include the header file, right? Because we are using this actor here. So for the header file, let's take a shortcut. We'll just include everything at once. We can just paste it in. Because in actual development, you definitely need to compare them one by one. Why use this character, etc. But I think we need this long. It shouldn't be a big problem, because some tools, like Writer, can automatically help you import files and such. Okay, here we need to find. That is, we need to create a filtering logic. That is, we must ensure that this character does not have this component. Otherwise, you will add it repeatedly. Next, we will take this thing of ours and attach it. Yes, attach the component here. You can see here, that is actually us. This is a method of the UC component. It's equivalent to attaching ourselves to the parent class. So regarding attaching to the parent class, it is attached to this component, and at the same time, its attachment rule is snap to target. Just that rule, and then this point is the position of this. That's all it needs. And then, since we are attaching a component, we might need to do what is called registration here, or some operations like that. That is to say, right here, there is a number 16, an operation on such a component. Okay, after these are done, this component of ours is already attached to us. Then we can activate it. When activating, we need to go up and down. Go get our current input subsystem. So right here, we just need to bring it over. It's actually the same as our previous operation. So this part is mainly divided into two steps. The first step is to get our controller. Then, after getting the controller, I need to get this subsystem. Then, after the subsystem, after getting the subsystem, we first take the input mapping we declared in the same file. We register it. Next, we register our action. So the action is registering a method like firing. That's it. Then we'll write this firing method next. For the firing method, let's first switch to the header file. How do we write it? Actually, it's just spawning a projectile. Just spawning a projectile. We can take a look. So first of all, you need to spawn a projectile. First, your character must exist. Your controller must also exist. Although it's very tedious, it's also necessary. Then, as for this class, it must not be empty. Otherwise, it won't even know what kind of thing you want to spawn. Do you want to spawn an ice spear, a fireball, or a bullet? You must specify exactly what it is. Only after you have this thing can we proceed to spawn it. This is of the U class type, and this helps us get the world, because it is already in the scene. We can get it through directly using the GetWorld method. If it is a pure object, sometimes you might not be able to get it. because you cannot get the GetWorld. So this GetWorld cannot be null after getting the GetWorld. It is not null, then we can spawn objects in this world. First of all, we still get our player controller, because we are the one who is going to spawn, who is going to initiate this attack. So here we get its what we call the provoker, or something like a generator. And then here we need to get our care controller, its own rotation, that is an angle or something. And then here we calculate the position where it needs to be generated. So first it gets this actor position plus the position of this gun muzzle, actually a coordinate conversion, because this involves a relatively complex kind of 2D space, 3D space. You need to look into this specifically, and how to convert the camera's view space into this three-dimensional coordinate, such a view space. We don't need to go into the details here, and here we simply make a rule. This rule is that if that is, there are many rules that when generating, this place is undefined. It always generates, this is for adjusting the position. If it can be generated, this is for not generating if there is a collision. This is for not generating if there is a collision. This is after adjusting the position. If there is a collision, in other words, it will not be generated. That's it. Okay, this is a simple rule. Okay, so at this point, we just need to, this word, generate its class for this word. Okay, here we just need to specify the negative class. We can do it this way. This is to spawn an actor using UWord. This is exactly the same as spawning an actor in Blueprint. Okay, this pair control doesn't seem to have made it into an ingested, or as we say, this concept, the pre-control here, actually just calculates this position and rotation. We'll ignore it, because we'll explain it later. That is, when you deal damage, that is, this player, he has a character, and then the player has a controller. The player has a gun in hand, then this gun will generate bullets, then the damage caused by this bullet. Who does it ultimately settle on? At this point, you need to pay attention. That is, in our GS, we need to distinguish who generated it and who used it. Like this. That is, when it finally calculates damage, what do you settle with? This will make it easier for you to do damage statistics later. That is to say, this character, how much damage he dealt, or how much damage this player dealt. This makes it more interesting. So this place emphasizes a concept of a provocateur, although we haven't used it yet. Okay, actually at this point, there is such an object in our scene, but this object should still have some issues, because we haven't written the methods in this projectile yet. We need to write them in the next 2 sections. Then this sound is relatively simple. We use gameplay static for this. This library is very important. Just use play sound, and that's it. This is the play sound node in Blueprint. Play sound is very simple. I won't go into this. Next, this is a bit tricky. That is, this animation blueprint is played through the anim instance. That is, our actor has a mesh. This mesh is this hand, this mesh. Then play these animation blueprint. These are all resource type. These resource classes, if yours is empty, don't come in. This will cause a brain crash. Now let's compile it. Okay, then let's take a look to see if there are any errors. Okay, there is an error here, right? But let's check where this error is occurring. For this kind of error, it's actually a anti-fun type. It's actually occurring here. This part belongs to forward life, so this is why. This is because we made a mistake here. You will see that we wrote 2 of these. Actually, we should have moved this one over. We placed it wrong here. Good, okay. If it's placed wrong, just leave it. Well, if it's placed wrong, we haven't written Paristia yet. Then let's go back first. Let's compile again. This compilation should work. Then let's go into the blueprint and test it. Ah, there's another error. Oh, that's good. This kind of error is Lincoln120. Let's check it, this kind of error. Like this, it just spits out a whole bunch of stuff. It means it didn't find the implementation of this method. Usually it's a header file include, or you didn't include it, or you forgot to write it. This error is also good to show everyone, because here, in the web comp, we have an underplay method that hasn't been written, because this weapon component. You might have many weapon components. For example, you have knives, swords, clubs, and staffs. So for your different weapon components, you might implement this dynamic mounting and Mounting a pro this underplay does not mean the game is over. It just means this component has been removed and destroyed. Because if the bullets in this gun are used up, then this gun might need to be recycled. So at this point, we need to directly remove the corresponding registered mapping. That's the idea. That is, we no longer need this to fire, because next time you might be using the golden cudgel, or similar situations, you might need to register another weapon component. So this involves how to design it. That is, you can design a weapon component. Then below, there is a gun component, a knife component, then a staff component, and they all have methods like underplay and begin play. But they all have this fire method. So when you call it, you can call the weapon component, thus achieving polymorphism on this weapon. This is a good opportunity to explain to everyone. Okay, so here we are. Let's go back to our game file. Previously this place was empty, nothing was written, but now we need to write something. First of all, we need to add something. Actually, this method is called composition because we are inheriting from actor. And this method is called inheritance. Do you understand what I mean? Generally, composition is better than inheritance, but in actual development, we use both approaches. Okay, here we need to add a weapon component. It can be received here because we added elements and tags to it. Then we can use it as directly as the root point. Then here we add another pickup component. Okay, there is such a pickup component. As for this weapon, we need to do some simple settings for it here. First of all, we definitely need to set the skeletal mesh. It should be here. Just set up the gun. Okay, after setting it up, we definitely still, for this gun, we definitely still need to do some work. We also need to specify the projectile class. Remember, it starts with BP. Because I often click on this one, but actually you need to use this one starting with BP. As for this sound, there should only be this one in the scene right now. And there is only this one fighting animation montage. And this is a weapons. In plexing is this short. Good. This completes a resource configuration. This is fine, no problem. Then next we click on this pickup. Here we will have an unpickup. We just need to implement this method. So here, first of all, we trigger here. After triggering, we take out this component. For this component, we will attach weapons. So here, we pass this object into it. After passing it in, we need to determine whether the touch was successful. Because why would it fail? Because there might be several guns in the scene. He already has a gun on him. So if the touch has already succeeded, then we need to play. We need to adjust our animation blueprint. We need to get an ammo instance. Get this ammo instance. This animation blueprint should be his animance instance. After getting it, we cast it to true. This should be called fast step. Then inside this, there is a Boolean variable. It is called whether to have a gun set or refire. Right? Okay. So this variable, after this thing, we can then change its posture of holding the gun. Okay, now let's test it. We'll just put this gun here. Okay, now let's try it. We go and bump into it. You can see, right? Okay. You can see the one on my right. The actor on the right is increasing, but it isn't right. That's because we haven't written the logic inside yet. But the entire logic of this gun is okay, completely fine. And note that this logic is different from our previous blueprint logic. This is pickup. It picks up and equips it onto itself. Whereas before, we picked it up and destroyed the one in the scene, then spawn one on the character. So you need to be aware of these two demos. They actually have the same effect, but logically it is different. So it is like this. Let's think about it. We will stop this lesson here. Next, we will implement the logic for this projectile. Okay, let's stop here for now. Thank you everyone.